So we're going to begin our unit on quadrilaterals, talking about generally angles in any polygon. So previously we've looked at the difference between interior and exterior angles. So interior angles are just the angles on the inside, the interior of a polygon, in this case a triangle. And the exterior angles, we can't think that the exterior angles are just the outside, because technically this is the outside. And that doesn't really help us. So actually the exterior angles are if I continue a side, any side, if I just continue it outwards, then the exterior angle would be this. So notice that these interior and exterior angles are supplementary. And that's going to be a key concept for us later on. But that's what an exterior angle is. All right, so let's look at some polygons and what the sum of their angles is. So this is a triangle, it has 3 sides, and we know that the sum is equal to 180. This is a rectangle, or it looks like a rectangle, it has 4 sides, and if each one of these is 90 degrees, it adds up to 360 degrees. But this is a pentagon, it has 5 sides. So how do we figure out how many sides there are, or what the sum of the interior angles is? Well, if I think about a triangle having 180 degrees, notice that this rectangle is nothing more than 2 triangles. Likewise, this pentagon can be divided up into 3 triangles. So of these triangles, this is 180, this is 180, and this is 180, making this 540 degrees. Now that's great, but what about when I have shapes with more sides? So this has 8 sides, and this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 sides. Am I going to sit here all day and just make triangles? No. So let's actually look at these. So 3, 4, and 5. So if I look at the number of sides that I have, so 3, 4, 5, the sum of the angles, so 180 degrees, 360 degrees, and 540 degrees. Notice I'm adding 180 each time. So what am I multiplying 180 by? Well, I'm multiplying 180 by 1. Here I'm multiplying 180 by 2. And here I'm multiplying 180 by 3. So is there a pattern that you see? Well, these are all counting up by 1s. So what's the difference between the sides and this last column? If we subtract 2 from the sides, we're going to get what we multiply 180 by. So that means that to find the sum of interior angles, we can take the amount of sides that we have, subtract 2, and multiply by 180. So if I have 5 sides, 5 minus 2 is 3, and 3 times 180 is 540. If I have 8 sides, then I do 8 minus 2 times 180. And so that's going to be 6 times 180, which is going to be 1,080 degrees. For 11, it's 11 minus 2 times 180. Well, that's 9 times 180, which is 1620. All right. Simple enough. So that's called the interior angle sum theorem. That if I have n minus 2 times 180 is equal to the sum of interior angles for a polygon. And it would work for a triangle, right? 3 minus 2 times 180 is just 180. All right, now what about the sum of exterior angles? Well, what can sometimes help us, and here I have a pentagon, whoops, what can sometimes help us is thinking about a circle. Now, a lot of us know already that a circle has 360 degrees, right? If I jump and spin, it's a 360. So notice I have these lines going into this tiny circle there, and these angles all make up portions of a circle. But if I drag each line along each other, just like that, I expand this open, notice the angles don't actually change, but the shape does. These are exterior angles. If I add these exterior angles up, I'm going to still get that same 360 for the circle. So this is actually the exterior angle sum theorem. That exterior angles of regular convex polygons add to 360 degrees. Don't forget, convex means that no angle on the inside is greater than 180. So a pentagon, right? Each angle is less than 180, but if I had a shape like this, notice this angle in here is not convex. This is concave. This is convex. Okay? So if I know that the measure of an interior angle of a regular polygon is 108, we want to find the sides of, find the number of sides of an interior. Find the number of sides in the polygon. Well, I don't know how much these angles add up to, but I know that one is. So if this is one interior angle, then an exterior angle is going to be 180 minus 108, which is 72. So if I add 72 a whole bunch of times, or multiply it by how many sides there are, then this is going to equal 360, since all of the exterior angles add up to 360. So if I just solve for this, I actually get that n is equal to 5. Simple enough. So we can use our exterior angles for regular polygons to help get the answer there. We can also use our rules here. So here I have a quadrilateral. So I do n minus 2 times 180 is going to equal 4 minus 2 times 180, which is 360. So that means that 2x plus 2x plus x plus x is equal to 360. So 6x is equal to 360, or x is equal to 60. So maybe not too difficult right now for a quadrilateral, but I could give you a problem where you have 20 sides and you have to do 20 minus 2 times 180 and add up those angles. So make sure you're thinking about this logically, and please review these notes, know this formula as you go through these problems.